A uniform plank is pivoted at its midpoint. Two weights are added to the plank, one weight on each side of the pivot in the positions shown. Okay, okay. So pretty normal standard setup. Vertical force is applied to point X to balance the plank. What is the size difference of this force? So the moment of the force, there are two moments by the force, right? Or like three. Let's call them, one is the moment because of X, the other is moment because of let's call this A because of this box, and this one counter moment to our thing, and which is because of this thing, let's call it B, right? Now if you look at this as the center, this can move clockwise or counterclockwise, right? So I want it to balance out. So the moment caused by X, which is the moment caused by X. Now I'm going to make this a little complicated in equation form, but don't stress too much, right? I hope you understand what I'm trying to do. The moment caused by X, right? There's some moment caused by X. This moment is, I'll just as an indicator for myself, is going to be this, right? Plus there's a moment caused by A, which is also counterclockwise. So the sum of these moments need to be equal to this for this entire thing to balance out. So I'll say the sum of these moments need to be equal to the counter moment, which is the B, right? So they all need to be balanced out. Once we have that, can we work it out? What's the moment for A? Let's say the force applied is F, right? That's F times, what's the distance from the pivot? This is the distance from the pivot. Pivot is here, your hand's going to be here, applying the force as 4. So let's just say for F, right? Then you have the force over here, which is 12, times the distance, which is 2. So that's going to be 2 times 12, right? And all of this is equal to 2, because this is 2, times 8, right? Equals to, so that's 16, and that's 2 times 12 is 24, and the force is still 4F, right? Now F will come out to be 16 minus 24, and we're getting a negative answer. That's -8 divided by 4, -2 newtons. That's the force required, right? Now, why is it negative? Now, over here, I assumed the force was downward, like that, and that's why I put my moment as downward as well. Actually, this side is more heavier than this side even before you apply this, and it makes sense because there's a 12 Newton at the same distance compared to a counterweight of 8 Newtons at the same distance, right? So this side is already heavier, and I assumed the force was downward, so I kind of put it in my equation like that, and I'm getting, oh sorry, I forgot to put the negative sign, and my force is coming out to be negative. So the force was assumed to be in this direction, and that's coming out to be -2. So does it make sense that the force is actually upward and positive, right? Does that make sense? So let's finish this out. The force has to be 2 newtons. So C and D are out, and it needs to be upwards. That's what we figured it out. And it makes sense. It needs to be upward just by looking at it, which I should have done earlier, but I didn't. But yeah, I'm a math guy. Right? Does this make sense? I hope it does. The correct answer is B.